Okay, the aim of this video and a PowerPoint is to go over the content for chemistry paper 1 for Edexcel examination board. I am calling this last minute revision night before or the morning before. So the key content that will be covered is shown on the screen in front of you. Now you can pause this video anytime for your own use, and you can go through this in your own time. The idea is to have a short video to recap on some of the key concepts. So the first thing I want to start with is you will get some questions on type of substance. So make sure you can differentiate between ionic, metallic and covalent bonding. Both ionic metallic bonding have structures that are giant ionic lattices, or giant metallic lattices have high melting points because ionic substances have strong electrostatic forces of attraction between oppositely charged ions. So ionic means positive ion and negative ion force of attraction which is very strong. Metallic means a metal, a positive metal in a sea of delocalized electrons, strong force of attraction, lots of energy needed to break the metallic bonds, or high melting and boiling point. Metals conduct electricity because they have delocalized electrons that can carry charge. Ionic substances will not conduct when they are solids because the ions are fixed, but when they are in molten state or in a solution, the ions are mobile to carry charge. Covalent substances, two types. Giant covalent is like graphite, diamond. Form of graphite is graphene. Both graphite and graphene conduct electricity because they are hexagonal structure where a carbon forms 3 bonds, leaving the 4th electron spare delocalized. Diamond is what we call tetrahedral. No spare electrons, it's very hard. Both diamond and graphite have strong covalent bonds between atoms which need lots of energy to break. Graphite is used as a lubricant, used in electrodes because in electrodes it has delocalized electrons, so it can conduct. It's used as a lubricant because it's a layered structure with weak intermolecular forces which can slide. Simple molecular. So remember, covalent bonding is a bonding between shared pair of electrons between non-metal atoms. Simple molecular is everything that is non-metallic compounds which are not graphite, diamond or graphene. So water, carbon dioxide, noble gases, oxygen, they have weak intermolecular forces between molecules. The weak forces they're easily overcome, so simple molecular substances have low melting points and low boiling points. They do not conduct electricity because they don't have any delocalized electrons. Next topic is looking at states of matter, mixtures and separation techniques. Now, the advanced information does say they're not going to test you on state of particles in solids, liquids and gases. We should know this anyway because of stuff we've done in year 7, year 8 and 9. However, the separation techniques. Filtration is to separate a mixture of, let's say, sand and water. Crystallization is an extremely important technique, and make sure you know how to make crystals of copper sulfate. So simply the method is 1, mix solid and acid. Number 2, filter. Number 3, heat gently and leave to dry. leave the crystals to dry, or crystals will form as you leave the mixture to dry. Chromatography, separation of a mixture which have different RF values. The separation depends on solubility in the solvent and how well the mixture adsorbs or forms bonds with the what we call the stationary phase. Mainly we use chromatography for mixture of things like inks. Different substances will travel at a different speed up the chromatography paper. Distillation is separation of liquids of different boiling points. Simple distillation I describe as mixture of two liquids. Fractional distillation, like crude oil, is a mixture of liquids that 3, 4, 5, 6 liquids in a mixture which have different boiling points, and they will come at a different boiling point. They will be collected at a different boiling points. Fractional distillation of course is much more accurate and much more better way of separating. Now please note, this is just a quick overview of what's coming up. You do need to spend some time looking into a bit more depth. Next, make sure you know how to purify water. The potable water, meaning the water that we drink. And some of the processes is water is filtered, passed into a sedimentation tank where it's sediments, where gravel and sand settle to the bottom. Then the water goes through a water tower where chlorine is added to kill microorganisms, and that's one way of treating water. In some countries, pure drinking water is from seawater, which is purified by distillation. Next topic I want to focus on is an extremely important topic, and that is the topic of acids. Now please note, important things to note: an acid is what we call a proton donor, H plus donor. So all acids contain hydrogen ions. If pH increases, that means hydrogen ion concentration decreases. Now, what's the difference between a strong and a weak acid? Strong acid fully dissociates, weak acid partially dissociate. Fully dissociate means hydrochloric acid becomes hydrogen ions and chloride completely. Difference between concentrated: a weak acid can be concentrated, like carboxylic acids, like ethanoic acids. The word concentration simply means amount of solute dissolved in a known volume of solvent. So the more solute there is, the more concentrated it is. You will definitely get questions on acid-base reactions. Examples of acid-base reactions: hydrochloric acid and sodium hydroxide. It's a neutralization reaction where an acid reacts with a base. Sodium hydroxide is a strong base. The ionic equation, please learn this. Hydrogen plus hydroxide forms water. Other important acid-base reaction: acid plus metal oxide, that forms salt and water, and acid plus metal carbonate, which forms salt, carbon dioxide and water. Learn these reactions. Just go through the reactions in your notes or revision guides. How do we prepare soluble and insoluble salts? I've given you an example of how we can make copper sulfate. Copper sulfate is being made from an acid and an insoluble base like copper oxide. You also need to know how to make insoluble salts, like two solutions mixed together. I'll give you an example. Sodium chloride solution with silver nitrate solution. That forms a white precipitate of silver chloride. All we need to do is mix the two solutions, pass them through a funnel with a filter paper, filtration. The solid will remain back. You can wash the solid with little bits of water to get rid of any impurities and then leave it to dry. That's how we make insoluble salts. One more thing on pH. Remember, pH measures acidity or alkalinity. pH 1 means strong acid. The difference between pH 1 and pH 2 means pH 1 has 10 times more hydrogen ions. So each time the pH goes down by 1, the concentration of hydrogen ions goes up 10 times. Now, a really important core practical which I personally feel we need to focus on, and that is the investigating an acid-base reaction, because that will come up. It's mentioned in the additional information. Now, in terms of acid-base, my advice is, in your notes or in your revision guide, you should have this practical, and hopefully you've done it in class or you've seen some YouTube videos on it. All we're doing is we're taking a beaker of acid, let's say 50 cubic centimeters. We can measure its pH two ways. Either we can use a pH meter or we can use universal indicator paper. We add approximately 0.3 grams of a base like calcium oxide each time. We stir and we measure pH. We do this for about 6 different masses of calcium oxide. We plot a graph of pH against mass. The graph should look possibly something like that. And then at what point is neutralization achieved? Let's mark 7 on our graph, dot across to the curve, and then down onto the x-axis, and that's the mass that is needed for neutralization. Please keep in mind the safety. Acids are irritant, corrosive, most bases are corrosive, so we must wear gloves, we must wear goggles, and we should wash off any spillages in that sense. Again, look at this in a bit more detail, please, in your notes. Now, next one is calculation. So whether you're doing combined foundation, combined higher, or triple chemistry, you will know definition of empirical formula, simplest whole number ratio of each atom in a compound. So glucose has a molecular formula of that. So molecular formula is the actual number of atoms of each type of atom in a compound, and empirical formula of glucose will be just divide through by 6, will be CH2O. To work out empirical formula, list your elements. Let's say you've got a metal and a non-metal. What's their mass? Write the mass of those. I don't know, just making these up. Divide by the atomic mass of each metal and non-metal, and then you need to ratio your answer. Let's say it comes to that, and then the ratio is 1 to 2. So Mn2, etc. Just a quick example for you. Relative formula mass, simply add up the atomic masses of all atoms. So for glucose, carbon is 12, there's 6 of those. Add 12 hydrogens, each hydrogen has an atomic mass of 1. Add 6 times 16, because the atomic mass of oxygen is 16. Add that up, that will give you the atomic mass of glucose, and I believe it's 180. Concentrations in solutions. Concentration, learn the formula, is mass over volume, and that is concentration in grams per dm cubed. Simply, you know the mass, you know the volume, divide the two together. Just one point to be aware of: convert volume from cubic centimeters to cubic decimeters. Reacting masses is probably the most challenging part of this topic. So what I would advise you is, when you are working out reacting masses, and I'm going to give you a quick example of that, then let's say magnesium reacts with oxygen to form magnesium oxide. Balance the equation. So if the question says how much magnesium oxide is produced from 2 grams of magnesium, so what we will do is we will work out the moles of magnesium, which is mass over mR. So remember, moles is mass over mR. That becomes the moles of magnesium oxide, because 2 moles of magnesium form 2 moles of magnesium oxide, so it's 1-to-1 molar ratio. And then to work out the mass of magnesium oxide, you will multiply moles by the formula mass of magnesium oxide to get you the right answer. It's a very quick demo of what reacting masses are. So if you are doing combined science foundation, you can switch off now. Okay, so now I'm going to move on to what extra is required for combined higher. Okay, oh, moles is higher, by the way, so I'll just put that there. Right, whether you're doing combined and triple, you will get questions on electrolysis without fail. So please note, learn the definition of electrolysis. It's the splitting of an ionic compound using electricity. A molten compound is a compound that splits up into 2 ions only, a metal ion and a non-metal ion, like lead chloride or lead bromide, that will split into lead and bromide ions. At the cathode, you will form, cathode is negative, so bromide will become bromine at the cathode. The equation now is that. Okay, so that's at the cathode. Reduction happens at the cathode. At the anode, lead is oxidized to form lead. So that's at, my apologies, right? At the cathode, reduction, so that's cathode, sorry, lead 2 plus will go to the cathode and Br minus will go to the anode. That's right. So oxidation happens at the anode. Oxidation is loss of electrons. So can you see electrons are being lost? Reduction is gain of electrons, so lead 2 plus is gaining electrons. In terms of solutions, when we are looking at solutions, then please bear in mind that with solutions, you've got 4 ions, because a solution is something dissolved in water. So you've got sodium chloride solution, that's sodium ion, chloride ion, hydrogen ion, and hydroxide ion. The products, Cl minus will become chlorine and H plus will become hydrogen. Learn this equation, please. That's happening at the anode. Hydrogen. Hydrogen goes to the, my apologies, yeah. Hydrogen go to the negative electrode, which is the cathode. Okay. So just get this right, okay, because sometimes it just becomes a bit confusing. So just remember it as the negative electrode is the cathode. Reduction happens at the cathode. Hydrogen ion gains electron. The reason we don't get sodium produced is because sodium is more reactive than hydrogen ion. If we were doing electrolysis of copper chloride solution, then your product will be copper. Copper 2 plus will become copper and Cl minus will become chlorine. Okay. The practical, which I'm quite convinced will come up will be the practical of electrolysis of copper sulfate. Now, I do want to talk about this because I think it's an extremely important practical. So what do you need to learn here? Well, my advice is to learn the following. The reaction that occurs at the anode is copper going to copper 2 plus 2 electrons. The reaction that occurs at the cathode, what we call the half equation, is the mass of the cathode goes up, the mass of the anode goes down. The copper atoms in the anode loses 2 electrons, so the mass of the anode goes down. The impure copper at the anode is losing mass. So we're producing pure copper at the cathode, which is gaining mass. Make sure you can draw the apparatus to show electrolysis. You need an electrolyte, you need 2 electrodes, and you need power supply. Now, oxidation reduction. So I've already mentioned that cathode is the negative electrode, reduction happens there. Reduction is gain of electrons, and the anode is where oxidation happens, which is loss of electrons. In terms of reactivity of metals, group 1 metals are at the top of the reactivity series, gold, silver, copper at the bottom of the reactivity series. In the middle you've got zinc and iron. All the metals which are above aluminium in the reactivity series, they are extracted using electrolysis. The metals below aluminium are extracted using carbon. Metals are extracted from their ores. Ores are compounds found in rocks from which it is economically viable for us to extract metal. Displacement of metals means a more reactive metal will displace a less reactive metal from its solution. Like copper sulfate can react with zinc. Zinc will replace copper, and that's one way of extracting metals. Another definition of oxidation and reduction is gain of oxygen and gain of oxygen is oxidation, loss of oxygen is reduction. A good example of this is zinc oxide, because metal ores are oxides, reacts with carbon to form carbon dioxide and zinc. Zinc has been reduced, balance the equation by carbon, because it's lower down in the reactivity series. Phytoextraction, bioleaching, a question comes up all the time. These are basically biological methods of metal extraction. Phytoextraction is where plants are grown in soils which are rich in metal minerals. The plants absorb the minerals, store them in the leaves. Then the leaves are dried and burnt, and then the metals can be extracted using displacement. Copper is extracted this way. Bioleaching is where bacteria grown on a low-grade ore produces what we call a leachate solution, and then the copper can be extracted from there. Both methods are slow, but the advantage is they don't produce sulfur dioxide, they don't damage the landscape in terms of mining and so on. And the other thing you need to know is, please remember the extraction of aluminium oxide. Aluminium oxide is extracted using electrolysis. You produce aluminium and oxygen, and the half equations is where aluminium is aluminium ion at the cathode produces aluminium, and the oxide ion produces oxygen and 4 electrons. The balanced equation which I was trying to write here for this reaction is the following. It's where Al2O3 produces aluminium, 4 aluminiums and 3 oxygens. Life cycle assessment, just have a quick read of this in your notes of the benefits of life cycle assessment and the benefits of recycling metals. Right. If you are now combined science, that's the end of your content covered there. You can now close this video, and then the next part of the video, I'm going to focus on triple science chemistry. So far, whatever I've talked about, plus now is triple chemistry. Now, according to your additional information, the things to focus on, what are yields? Yield is theoretical mass or theoretical yield over actual times 100. Now you are expected to learn all your formulas. Your formulas are not given unlike physics. Atom economy, definition of atom economy is formula mass of useful product over formula mass of total reactants times 100. We don't get 100% yield because some reactions are incomplete. Not all reactants get used up. There are side reactions that take place, and product is also lost through transfer. Atom economy looks at how much of in a reaction, it's a theoretical concept by the way, how efficient a reaction is in making useful products. It helps us to look at which is the best way to produce a product. So you may have done a reaction of how to make ethanol. Ethanol is made two ways. Ethanol can be made by fermentation or by direct hydration from ethene. Both methods have advantages and disadvantages. Making from fermentation has low energy costs. It's a renewable process. However, the reaction is very slow. The product's impure. Making ethanol from ethene and steam produces a pure product. Very fast reaction, but it has extra costs. And also ethene is coming from crude oil, which is a non-renewable resource. Now, two important things I want to focus on. Calculations, including titration practical, and then the Haber process, which is equilibrium. So the formula for concentration you also need to know is concentration is moles over volume. So how do we do a titration calculation? A typical titration calculation is where an acid reacts with a base. So my advice is do this as a table. List the volume you know and the concentration you know. Normally, you will always be given volume and concentration of at least one of the substances. Then work out moles of a substance. Then use molar ratio to work out moles of substance 2. So let's say I know the volume of my acid and I know the concentration of my acid. Then I can work out the moles of my acid. Moles of my acid become moles of my base if it's 1-to-1 molar ratio. And then I can use that to work out the concentration of the unknown. Volume of gases, the formula is volume equals n times 24 decimeter cubed. Important formula to work out volume of gases only. Now, how do we do a titration? Simply make sure you are familiar with this technique. If you haven't done this practical, there are plenty of videos on YouTube. Just to GCSE titration, there's a nice video, AQA video on this, where the lady goes through the technique. You need a burette. You need a conical flask. Let's say you transfer 5 cubic centimeters of sodium hydroxide into the conical flask. You fill the burette with hydrochloric acid. you slowly transfer and you add an indicator. There are two indicators: phenolphthalein, which is pink in the base, goes colorless, and methyl orange, which is red in the acid and yellow in the base. You've got to know the colors of those two. We're going to add hydrochloric acid slowly. We're going to swirl the conical flask, place that on a white tile, and you're going to observe a color change, which in this case should go from pink to colorless. You repeat your procedure until we have concordant results, and concordant means results to 0.1 cubic centimeters. This method can be used to produce pure salt or crystals of sodium chloride. So what we would do is, if we want to make pure sodium chloride accurately, then we know how much hydrochloric acid we've added, we know how much sodium hydroxide we've added. So this time we measure the volume of HCl and the volume of sodium hydroxide, mix the two together. We don't use the indicator this time because the indicator will add an extra impurity. Then we gently heat the solution and we leave it to dry, and the salt or the crystal should form. If we just want the salt, then we can heat to dryness. Okay. Lastly, Haber process. Okay. Now, please learn topic 4 on equilibrium as well. We need to know the definition of dynamic equilibrium, and let's look at my Haber process. This is your balanced equation. The reaction is exothermic in the forward direction. Remember, left to right is forward and right to left is backward. In this reaction, we use a catalyst. The job of a catalyst is to speed up the rate of reaction. It speeds up the forward reaction and reverse reaction equally. Equilibrium is established quicker. There's no effect on the yield of ammonia. We need low temperature because the forward reaction is exothermic. So you will say low temperature moves the equilibrium in the forward direction because it's exothermic, and the yield of ammonia will increase. In terms of pressure, we need high pressure because the rule is high pressure moves the equilibrium in the side that has fewer moles of gas. The problem with high pressure is that it will give us more yield of ammonia. Reaction will happen faster, but high pressure is dangerous. It increases cost and there's a chance of explosion. And the problem with low temperature is the rate of reaction is slow. So we reach a compromise, and the compromise for this reaction is pressure of 200 atmospheres and temperature of about 450 degrees and an iron catalyst, and in these conditions we get a really good yield. Eventually we get about 95% yield in a good time. Another thing is, make sure you know how to make something like ammonium nitrate and ammonium sulfate. Okay? So how do you make ammonium nitrate and ammonium sulfate? Simply, this can be done as a titration reaction where ammonia reacts with sulfuric acid, and that will produce ammonium sulfate. Alternatively, you can have ammonia reacting with nitric acid, and that will produce ammonium nitrate. Both of these are used for fertilizers, and the advantage of this is a fertilizer will speed up the growth of plants. The advantage of doing this in industry is because the reaction is done in large scale, and it's a continuous reaction, and in the lab it is a batch process. And this reaction can be done as a titration, where we fill the burette with sulfuric acid or nitric acid, and we put 25 cubic centimeters of ammonia in a conical flask, and we do a titration and we look for concordant results, and that will give us the average acid volume of acid added to the base. Then we can measure those volumes of acid and base, mix them together, heat the mixture and let it dry, and then we can get our fertilizer formed in that way: sodium, ammonium sulfate and ammonium nitrate. I hope I've gone through this very quickly. I hope you found this useful, and it's helped you in terms